All right, the first problem that we're going to start with. In the atmosphere, nitrogen dioxide reacts with water to produce nitrogen monoxide and nitric acid, which contributes to pollution by acid rain. How many grams of nitric acid, so this should be a subscript, my subscripts didn't work when I was writing this, I'll fix it later. How many grams of nitric acid are produced for every 1 mole of nitrogen dioxide that reacts? The molecular weight of nitric acid is 63 AMU. Okay, so let's take a moment to think about what is happening in this problem. First of all, we're given this chemical equation, and we're going to need to ask ourselves if it's balanced. If it is not balanced, we will balance it. Once it is balanced, you will then need to figure out, what is this problem asking me to solve? It's asking me for every 1 mole of nitrogen dioxide that reacts, how many grams of nitric acid is formed? Okay, we'll talk about that when we move on to the whiteboard so we can understand the steps that are required for this. Because we cannot convert from moles of one substance directly to grams of another substance. We need to have the mole-to-mole relationship first. From moles of one substance to moles of another substance, we'll be using the balanced chemical equation. So let's start with the balanced chemical equation. We are reacting nitrogen dioxide, NO2, that is a gas, is reacting with water to form nitric acid, which is going to be considered aqueous because it's dissolved now in the water, and then NO, nitrogen monoxide gas. Okay, looking at this, what I'm seeing is that the hydrogens are not balanced and the oxygens are not balanced. Okay, let's practice with our table again, just so you remember that you have that option to use a table. Left side, right side. Nitrogen, hydrogen, oxygen. Okay, 1 nitrogen on the left, 1 nitrogen on the right. 2 hydrogens on the left, 1 hydrogen on the right. So what am I going to do here? I'm going to put a 2 in front of the HNO3. Now, we have 2 plus 1 is 3 oxygens on the left. 2 times 3, because this gets distributed to the oxygen. 2 times 3 is 6, plus 1 is 7. Now, let's think about this. How are we going to be able to balance if we have 3 here on the left, but 7 on the right? Okay, let's think about this for a moment. Now, I just realized now the nitrogens, we had 2 nitrogens on the left. Oops, I just noticed that. Okay, teacher makes mistakes. That happens. Okay, so then if we have two, now we also have two, now we have actually three nitrogens on the left. Okay, so we started with two, now we have three. So then now, in order to balance the nitrogens, we need to put a 3 in front of the NO2. Okay, now what does that give us? That now gives us 3 times 2 is 6, plus 1 is 7. Magically worked, just because I noticed that we didn't count that other nitrogen. Very good. So by putting a 3 in front of the NO2, that now gives you 3 times 2, which is 6 oxygens, plus 1 oxygen here, gives you 7 on the left. And then let's double check again. 3 times 2 plus 1 is 7 on the right. And now it's balanced. Okay, so now what does this mean? What this is telling us now, remember, when we have a balanced chemical equation, it is giving us a recipe. So the recipe here is telling us that 3 moles of nitrogen dioxide is reacting with 1 mole of water to form 2 moles of nitric acid and 1 mole of nitrogen monoxide. Now that we have our balanced chemical equation, let's think about what the original problem said. The question asked us, how many grams of HNO3 is produced or are produced for every 1.0 mole of nitrogen dioxide that reacts. Okay, so let's identify our known information. Our known information is that we have only 1 mole of nitrogen dioxide that's reacting, okay? Because we want to know just for every 1 mole that reacts, how much is being formed, okay? So that is our known information. The given information is 1 mole of nitrogen dioxide. We want to convert that to grams, okay? So for every 1 mole, so we're starting with 1 mole of nitrogen dioxide, and we want to convert this to grams of HNO3. Now, we cannot convert directly from one substance to another substance. That's a no. We can't do that. But what we can do is convert from moles of one substance to moles of another substance. So we're going to convert this from moles of nitrogen dioxide to moles of HNO3. Then from moles of HNO3, we can go to grams. Now, when we're converting from moles of one substance to moles of another, we need the mole ratio in this step, okay? What's the mole ratio between nitrogen dioxide and nitric acid? For every 3 moles of nitrogen dioxide, 2 moles of nitric acid is formed. So that means we're going to use the conversion factor of 3 moles of nitrogen dioxide per 2 moles of HNO3. That is your first step. You will convert moles to moles using the mole ratio. Then grams, we use molar mass. You are given that the molecular weight is 63 AMU. Remember, the molecular weight is the same as the molar mass. So 63.0 grams per mole is the molar mass. Okay, so now that we understand the problem and we have our plan, we're going to do the calculations. The first thing that you start with is your given information, the 1 mole. We're going to convert to moles of nitric acid, then to grams of nitric acid. So that's our plan, and I'm going to erase that to give myself some space. You always want to make sure you understand the problem before you start doing any calculations. Okay. So this was the question. Okay. So we're starting with our given information, 1.0 moles of nitrogen dioxide. Now, we want to get to grams of nitric acid. Before we can get to grams, we have to go to moles. So we use the coefficient in our equation, 3 moles of nitrogen dioxide per 2 moles of HNO3. So for every 3 moles of nitrogen dioxide, we are forming 2 moles of nitric acid, okay? But we're only reacting 1 mole of nitrogen dioxide. But when we do this calculation, it will consider what it would be if it was only 1 mole. This is saying 3 moles produces 2 moles. Now from the moles, we're going to convert to grams. I want you to get in this practice of using multiple step conversion, because it will make your calculations easier to make sure that you understand the steps that are being taken, okay? So just continue your calculation now from moles of nitric acid to grams of nitric acid using the molar mass, which we said was 63.0 grams of HNO3 per 1 mole of HNO3. Cancel out those units. Now, 1 times 2 divide by 3 times it by 63 will now give us the mass of nitric acid that would be produced. What I am getting is 42 grams of HNO3.